Hello, everyone. How are you guys doing today? Good. So I'm not going to go over the review sheet. I just want to show you that the recording from last class, it's on our class page. The first video is the recording from the last class. So I went over whatever will be in the exam. I told you what will be in the exam. And I also went over a few questions from the review sheet. So make sure to watch it, and your exam will be day after tomorrow in class. Okay? Past day in class, day after tomorrow. Definitely don't be late. And also, don't miss the exam. Okay? Any question before we start? Any comments? Concern? Complaint? Nothing? So we are starting derivative. So calculus, even though it's a pre-calculus class, but we are going to do little calculus the rest of the semester. We start with slope of the curve or slope of any curve. So from chapter 1, we know that the slope of a line that goes through 2 points is y2 minus y1 over x2 minus x1. That's the slope of any line that goes to 2 points. Now, if we assume that x1 is just x and x2 is x plus h, what does that mean? Let me draw a picture for you so that it will be easier to visualize. Draw. So let's say we have a point here and we have another point here, and we are trying to see the slope of this line. So this point is x1, and here we have x2. Now, if you say our x1 is simply x, that means our x2 will be x1 by x plus a little bit more, right? So it's x plus some more units. X1 is x, x2 is that x plus a little bit more x values. So our y1 is f of x. Here, this is y1, which is f of x. And this point here is y2, which is f of x plus h. So if you if you change the variables a little bit around, then the same equation y2 minus y1 over x2 minus x1 turns into a new equation, f of x plus h, which is y2, minus f of x, which is y1, divided by x2, which is x plus h, minus x1, which is x. It's the same slope, same formula, same everything. They just look different. And on the denominator, you see that positive and negative is cancelled out, so we have h only. So in the numerator, we have f of x plus h minus f of x. On the denominator, we have h. So now I'm saying this is the slope of a line that goes to 2 points. But this one also is another name, right? What's another name for this thing? Who remembers? Does it look familiar to you? Quotient. Difference quotient. Difference quotient. So if you didn't notice it before, Now you're observing that the difference quotient is actually the slope of a line that goes to 2 points. Okay. Now, here, we are not looking for slope of a line. We want to find what is the slope of a curve. Okay. So curve could have any shape. One of the curve is parabola. So let's see the parabola. So slope needs 2 points, right? If you want to find slope, it needs 2 points. So let's say we are taking 0, 0 and 3, 9. So our x is 3, our y is 3 square 9. So what's the slope of the line that goes through these 2 points? You substitute y2 minus y1 over x2 minus x1, and we get the slope is 3. So this is our graph. Our 0, 0 is here, and 3, 9 is here. This is the slope of the line that goes through these 2 points in our parabola. Now, let's see what's the slope of the line that goes to different points. So we are taking 0, 0, and this time 2, 4. Point x is 2, or y is 4. So what's the slope of the line that goes to 0, 0, and 2, 4? So this is 0, 0, this is 2, 4. When you use the slope formula, we get half of 4, which is 2. So this point and that point, this line has slope 2. Weird, right? For a line, it doesn't matter which 2 points you take, any 2 points will give you the same slope. If you have a line, like let's say this line, the slope between these 2 points is the same slope between these 2 points. Okay? In a line, slope never change. The slope is always same. So you can take any 2 points and you get the same slope. But for a curve, is it true? If you take any 2 points, do you get the same slope? No. What happens when you take a different point? Unless you're taking 0, 0 and 1, 1. So our x is 1, our y is 1. So for 0, 0 and 1, 1, the slope is 1. So this point and that point, they have slope 1. And now if you try to see something that is closer to 0, 0.5. So 0.5 square is 0.25. So when you take the slope is even 0.5. So different, that slope between 0, 0 and 0.5, 0.25 is 0.5. So isn't it weird? A curve has so many slopes if you change your points. So how can you find the slope of a curve? Unfortunately, we cannot find the slope of a curve that goes, we cannot find a fixed slope that goes through any 2 points. However, we can find something that goes through only 1 point. We can find what the slope of the line that goes through this point, or that point, or this point, or that point, like any 1 point. We can find the slope of a line that goes through only 1 point. Okay, and that slope, depending on the slope formula, is a unique formula. Like this slope formula is unique for any line, but depending on your graph, your slope formula is different. Now, if you pick even full size, 0.25, 0, 0 and 0.25, we get the slope 0.25. What are you observing here? Slope between 0, 0, 3, 9 is 3. Slope between 0, 0, 2, 4 is 2. Slope between 0, 0 and 1, 1 is 1. Slope between 0, 0 and 0.5 is 0.5. Slope between 0, 0 and 0.25 is 0.25. So if I want to find what's the slope of this curve, point x is 0, can you estimate by observing all these points? See, we are the first point farther from 0. Second point is a little bit closer to 0. Third one is a little closer to 0. Fourth one is a little closer to 0. Fifth one is even very close to 0. So if our goal is to see what's the slope of the curve at 0, only 1 point at 0, by observing all these slopes, can you guess what will be the slope at 0? All these numbers are going toward which number? Closer to 0. So we can guess that if you pick another point that is closer to 0, it will be definitely, the slope will be closer to 0. So the more you go closer and closer and closer and closer, we can get an estimate on what is the slope of the line exactly at 0. The answer will be 0. Okay. Unfortunately, we cannot find exactly at 0 using 2 points. So if you want to find what's the slope of the line at 0, 0, then our second point will be 0, 0, right? If you want to use this formula, y2 minus y1, we need 2 points. And use the same 2 points, y2 minus y1 over x2 minus x1. Everything is 0, 0, 0, 0. So we have 0 over 0. What is 0 over 0? Is it 0? What is 0 over 0? Doesn't exist. So we cannot find the slope at 0 using slope formula. So we cannot use a formula. That's why we invented derivative. What's the derivative? Derivative is the slope of the line that goes through that 1 point we are looking for. Okay. So how do you find the derivative? Well, what you do is we start with a line that goes through 2 points visibly. Anytime you see a line that goes through the 2 points of a curve, we call that line secant line. Secant line goes through 2 points of the curve. And then we move the secant line closer and closer and closer and closer to the point we want to find the actual slope of. So the secant line of this secant line is it slope 3. This secant line is slope 2. The next secant line is slope 1. So we are moving our secant line. If you start from the top, then you're moving. So this is your first secant line. Then you want to see what's the slope for the second secant line. So you do this one. Then you try the next one, and then you try the next one. And then we see how the secant line is changing.
But it took by a seat.
Toward, then grab another seat. I was saying, okay. So we observe the secant line, and we see if we move the secant 2 points in the secant line closer and closer and closer to the line, to the point we are looking for, then that's the slope of the derivative. I mean, that's the slope of the line we are looking for. So when the line goes to only 1 point, we call that line a tangent line. If you have a line that goes to 2 points in the curve, it's called secant line. And if your line goes to only 1 point at 1 point on the curve, we call them tangent line. The derivative is a slope of the tangent line. Okay? So what's the definition? The definition is this. I don't have the definition yet. Okay. Before going to the definition, let me tell you the relationship between secant and tangent line. Why I'm talking about secant and tangent line? Why? Well, that's because they have a relationship. They have a connection. The tangent line gives us the derivative, which is the slope of the line, which is the slope of the curve at 1 point. And that slope we can find by taking the limit of your secant line. It means you change your secant line, the distance between the 2 points in your secant line, closer and closer, means the limit of the difference is going to getting 0, closer and closer to 0. If the difference is getting closer to 0, eventually the secant line turns into the tangent line. So the tangent line is the limit of the secant line. And when you take the limit towards 0, what does that mean? What am I talking about? I'm talking about this. When the slope of the secant line is f of x plus h minus f of x over h, which is the same slope, which you guys missed, is same as y2 minus y1 over x2 minus x1. This slope and this slope, they're the exact same thing, and this is the slope of the secant line. If you take the limit over the x values, means make your x values closer and closer and closer and closer, so there will be no difference between these two x values. If you make these two x values, x2 and x1, closer and closer, closer to one another, whatever you get, that's the slope of the tangent line, and that's the derivative of your curve at a particular point. Lost? Main idea. Derivative is a fancy word. It means you are looking for the slope of the curve at one point. It's not slope of the curve that goes to 2 points. Slope of the curve that goes to 2 points is a secant line, which easily can be found using the slope formula. But slope derivative, the curve doesn't have one fixed slope. At every point, it is a different slope. So the question is, how do you find the slope at every point? To find the slope at every point, instead of having one equation, instead of having one fixed equation like y2 minus y1 over x2 minus x1, we get one fixed equation that will give you the slope at any point, anywhere in the curve. And that equation is called the derivative of the function, a derivative of the curve. So by definition, the derivative of the curve is the limit of your slope of the secant line. This is the definition of the derivative. So how do you express that? There are many ways we can use this derivative word. When you see f and then little thingy on the top x, it's called f prime of x. It means derivative of the function at x. Derivative of the function at x, we call it f prime of x. Or you can see the word dy dx, it means derivative of y at x, not at x. Derivative of the y in terms of x. This is called y prime of x. It means derivative of the y at x. And also you may see d over dx f of x. It means derivative of this function in terms of x. They all mean the same thing, they just look different. So in different places in your book, you'll see different notation. All notation means the exact same thing. You are working with derivative of the function. And now if you want to say the derivative at a particular number or at a particular point, let's say the point is a. So we say derivative of the function at a. Y prime at a. dy dx means derivative of the y at x. And the last one is derivative of the function at a. A means any number, and x means it's general. For any number x, what's the slope? We find that slope as an equation, and then let's say you want to find the derivative at 0. We substitute 0 with x. If you want to find the derivative at 5, you substitute x with 5. So we find a particular place, a particular equation which we can use to find the derivative of any point in the curve. So we have a curve. The derivative here, so the slope here will not be the same as slope there. The number is different. In here, the slope is positive. In here, the slope is negative. But how do we find them? We find them by taking the limit of the actual, what do you call it? slope formula. Limit of the slope formula, which is a limit of the slope of the secant line. That will give us those numbers. What number we have? At x equals less than 5, this is 2. Later, we are going to learn how to find the derivative without using calculator to make our life easier. Sorry, without using the definition to make our life easier. But for now, it says use the definition of the derivative and figure out what's the slope of this function. So they are saying evaluate the following. Means basically what's the slope? What's the slope of the function y equals 5x squared at any x? What's the slope of this function at any x? Well, for this question, we're not going to do any calculus. Instead, we are going to do algebra, like the difference question you did before. You're going to not split. You're going to FOIL this. So we have 5x plus h times x plus h minus 5x squared divided by h. Do you remember your difference quotient? So we're doing difference quotient here. Limit h goes to 0. And when you use the distribution, you get 5x squared plus 2xh plus h squared minus 5x squared over h. And then you distribute to 5. So you get limit h goes to 0. 5x squared 10xh plus 5h squared minus 5x squared over h. What do you notice? Do you see anything here? Can you cancel anything here? 5x squared. Anything else? No. So we do limit h goes to 0, 10xh plus 5h squared over h. You can split that into 2 pieces, or you can take h as a common factor. 10xh over h plus 5h squared over h. That gives us limit h goes to 0 of 10x and 5h. I'm doing algebra, nothing else, just algebra. And then we work with limit. So what does limit mean? Limit means we can substitute h with the limiting value if you don't have any problem. Here we cannot substitute h with the limit because then denominator is 0, everything becomes undefined. So we cannot substitute the limiting value until there is no problem. So if you substitute h with 0, we don't get anything invalid. So this time we substitute h with 0 and we get 10x plus 5 times 0, which is 10x plus 0, which is 10x. What does that mean? It means the slope of this function at any point in this curve has a formula 10x. Now, with this formula, you can find the slope anywhere in the curve. If you want to find slope at 0, the answer is 0. The slope is 0 there. If you want to find the slope at 5, the slope is 50. If you want to find the slope at -2 of this curve, the slope is 10 times -2, which is -20. So every point in the curve, so this is your curve, 5x squared. Every point has a different slope. It doesn't have a fixed number for the slope. It has a fixed equation for the slope. If you can find this fixed equation, it doesn't matter where you're looking for your slope. All you have to do is take the number, take the x value, substitute here, and you see your slope. Okay? So that's the derivative. Slope of the curve at any point. What's the slope of the curve at any point? That's the derivative. And it has few fancy names. For example, find the derivative is same as find the slope of the tangent line. Or find, do I have it here somewhere? Right, derivative means slope of the curve or slope of the tangent line. Later, we are going to learn many more fancy names. But for now, if you see the word derivative or find the slope of the curve or find the slope of the line, tangent line, remember they all mean same thing, find the derivative. So using the formula, using the definition, how do we find the derivative? The definition says the derivative is limit h goes to 0 of your difference quotient. So all you have to do is find the difference quotient, take the limit on it, and you see your derivative. Okay, that's all you have to do. One example. Find the derivative has another fancy word, differentiate. You'll see they all say differentiate. It means find the derivative. So differentiate, find the derivative, find the slope of the curve, or find the slope of the tangent line. They all mean same thing. So we are going to use the definition here. The definition says definition of derivative. It says derivative of the function anywhere at x is the limit h goes to 0 of f of x plus h minus f of x, whole thing divided by h. This is the definition of the derivative. Now this time our function is x squared. So this thing here is minus x squared. So if f of x is x squared, then what is f of x plus h? X plus h whole thing squared. So f of x plus h, sorry, what I'm saying, x plus h whole thing squared minus x squared divided by h, take the limit on it. F of x is x squared, so you're subtracting your f of x means you're subtracting x squared, and then we have f of x plus h means x plus h whole thing squared. And then what we did before, we're going to do the exact same thing again. Limit h goes to 0, x squared plus 2xh plus h squared. So when you expand this, you get that. You're subtracting x squared. At the end, you're dividing by h. It's almost 8. And now you substitute to 8. So you get 2x plus 0, which is 2x. So this is A. Find the derivative of f of x equals x squared. Now B says once you find the derivative, now find out what's the derivative when x is 3. So A is derivative of x, the answer is 2x. B is asking derivative at 3. So what's the answer? 6. 2 times 3, 6. So you use the difference quotient, you find the difference quotient, and then you apply the limit on it. Applying the limit means h becomes 0, so there will be no more h. Whatever it means, that's the equation of the derivative, means the equation of the slope at any point in your curve. Any questions so far? Don't tell me I didn't understand anything. Good, I'm happy to hear that. Good job. That means now we are finding the actual line, the tangent line I'm talking about. So if this is your curve, and you know the tangent line that goes through this point, the tangent line has a slope 2x. Okay? Now the next concept is what's the equation of this tangent line? So tangent line is a line that goes through one point of the curve, only one point. Derivative is the slope of the tangent line, so let me write it down. The slope of the tangent line is the derivative. To find the equation of the tangent line, we know equation of any line is y minus y1 equals slope times x minus x1. That means all you have to do is you need to find what is y1, x1, and the slope. So they will give you the x1 always. They'll give you that. If they do not give you y1, then your first step is take this x1, put it in your formula, and then see what's that y value for that. So you get y1 for x1 if it's not given. If it's given, your life is easy. You don't have to find it. Take the x1, substitute it with the function to get the y1. Step 1. Step 2, find the slope using the definition of the derivative. So this is the slope equation. We cannot use slope equation. We need the slope number. So what we do, we substitute the x value into the slope to get a numerical value for our slope. So we have x1, we have y1, and we have a number for the slope. We substitute here, solve for y. That's all you have to do. Start with x1. If y1 is missing, find the y1. Once you have your x1, y1, then you're looking for the slope. Slope is the derivative. Once you take the derivative, that will give you a formula. But we cannot use the formula. So you have to substitute x in the formula to get the actual number. So x1, y1, the actual number of the slope, substitute, solve for y. Let's do one example. Find the equation of the tangent line of this curve at x equals 2. So x squared, it's something like this. X equals 2. Let's say this is 2. We want to find what's the equation of the line that goes through x equals 2. That is our goal. So step 1. We know that x is actually the x1. x1 is 2. Did they give us y1? No. So our first step, find the y1. So what do? Take this x2, substitute, get the y1. So take this x1, substitute to the function to get the y1. So 2 square plus 3 times 2 minus 1, which is 4 plus 6 minus 1, 9. So we found our y1 is 9. So x1, y1, we have both of them. We're happy. But the only missing thing is the m. So as step 2, what's the m? We need to use the formula, the definition of the derivative to get the slope equation. So slope, I should write slope equation, not the slope number. Slope equation is limit h goes to 0, f of x plus h minus f of x divided by h. So limit h goes to 0. If our f of x is x squared plus 3x minus 1, what is f of x plus h? What is our f of x plus h? X plus h squared plus 3, x plus h minus 1. Pedro, what do you get from here? Not factor, you have to expand.
Oh.
I thought you were giving your factoring out. Sorry, my bad. Plus x plus h minus 1. And then what do you get from here?
Yeah, x squared plus 2xh plus h squared.
Perfect. X squared plus 2xh plus h squared. 3x, 3h, and then minus 1. So we are going to put this entire thing in place of this f of x plus h. The entire this thing goes here. X squared plus 2xh plus h squared plus 3x plus 3h minus 1. And now we are going to subtract f of x. When you subtract f of x, what happens to all the sign? They swap, they change. So negative f of x means negative x squared, negative 3x, positive 1. So that entire thing goes here. Negative x squared minus 3x plus 1. Whole thing divided by 8. So this was extra. We have limit h goes to 0. And what do you observe in the numerator? What do you see in the numerator? X squared, what else? 3x, and then 1. So what is left? And you divide all of them by h. So limit h goes to 0. 2x plus h plus 3. And then what's the last thing we do? H becomes 0. So there will be no more h. It's 2x plus 3. Step 2 says use the difference quotient. The difference quotient is subtracting the original function from f of x plus h. So first you need to find what is f of x plus h. This is f of x plus h. All the x becomes x plus h. And then you expand everything. And then you're going to subtract f of x. So when you subtract f of x, this f of x will change all the sign. The positive x squared is negative, positive 3x is negative, negative 1 is positive. So this is negative f of x. And then you cancel whatever is cancelable. Once you do all the cancellation, then you do the division by h. So there are 1h, 2h cancel out. You have only 1h in the middle. So this time you apply your limit. If you substitute h with 0, then you get 2x plus 3. This 2x plus 3 is the derivative at x, which is slope at x. But we are not looking for slope at x. We are looking for slope at what? X equals 2. So next, find out what's the slope at 2. Slope at x equals 2. So slope is 2 times 2 plus 3. So what do you get? 4 plus 3, which is 7. So we found our x1 is 2, which was given. We found our y1, I forgot, y1, 9. And we just found our slope, which is 7. So we have all the information to find our equation of the line. So we go ahead and find the equation of the tangent line at x equals 2. Y minus y1, slope x minus x1. So y minus what? 9. What is our slope at 2? 7. X minus, what is our x1? 2. So y minus 9, you distribute, you get 7x minus 14. To get the y alone, what do you have to do? Add 9. So y equals 7x minus 5. So the line we are talking about before, if this is your graph and this is x equals 2, the line that goes through this point, this line has equation y equals 7x minus 5. And the slope of this line is 7. Slope of this line is 7. The equation of this line is y equals 7x minus 5. Why do you care? Because this is the derivative of this is the slope of this part at that point, which is also known as the derivative. The step 2, we found the derivative equation. This is step 3. Once you find the derivative equation, you need the derivative number. So you find the number. Once you have the number, then this is your last step. Step 4, and this is your step 5. Solve for x. Sorry, solve for y. So main idea, steps. X1 will always be given. If y1 is not given, find y1. If it's given, we don't have to worry about that. Once you have x1, y1, you need to know the slope. How do you find the slope? We take the derivative. Once you have the derivative, you get the equation of the slope, which is unnecessary. I mean, we cannot use the equation in our equation of the line. So we need the number for the slope. So we substitute the x value into the formula to get the slope number. Once you have the number, you substitute x1, y1, and the slope number. So for that. That's the equation of the tangent line. Question. Good news, we're not going to use the definition. Definition takes longer, right? After your exam, when you come back, we are going to learn shortcut to find all these derivatives, which is much simpler. But then the next topic is horizontal tangent line. Not in this test, it will be the third exam. Exam 3.
It's Thursday.
We had this discussion before. We don't have a midterm. We have quarter term. Means we have 4 exams in the semester. Oh. So each exam is a quarter. So yeah, this one you can call midterm because it's second quarter. Midterm. Yeah. Okay, yeah, horizontal tangent line. So we know the tangent line has different shapes. Some tangent line. So let me. So this tangent line is positive. If you want to find a tangent line here, this tangent line will be negative, right? If you want to find a tangent line here, this tangent line will be vertical. And if you want to find a tangent line here, this tangent line will be horizontal. Tangent line could be anything. Horizontal, vertical, increasing, decreasing. It has all types of shapes. One very important tangent line is horizontal tangent line. A horizontal tangent line means here. It's a horizontal line. It touches your parabola, it touches your curve at one point, somewhere here. Or maybe it's upside down and you have the tangent line here. Okay. So horizontal tangent line means when your tangent line is horizontal, straight horizontal. So we already know from before, you should remember that the slope of any horizontal line is what? Slope of any horizontal line is 0. The answer is in front of you. Come on, guys. From before, you should know that, but you still have it here. That means once you find the equation of your slope, you just have to set that derivative, which is the equation of the slope, equals 0, and they will tell you what's the, for which x values you have a horizontal tangent. So what do? We take the slope of the derivative, which is the derivative of the curve. We set the derivative equals 0, solve for x. We get the x values that gives us horizontal tangent line. Why do we care? Because as you observe, horizontal tangent line gives us either maximum or minimum of your curve. And you always want to see maximum or minimum. Horizontal tangent lines are important because they give us local maximum or local minimum. For example, if you have a curve like this curve has a turning point here, a turning point here, a turning point here, and a turning point here. There are so many turning points, and every of these turning points, each of these turning points has a horizontal tangent line. Horizontal tangent line, horizontal tangent line. So if you don't know the shape of your curve, you can already guess how many turning points your graph has, or how many local maximum or local minimum your graph has. For example, these are local minimum, and those are local maximum. We have two local minimum, two local maximum. We can find these without using the graph, just by using horizontal tangent line concept. Okay? Let's do an example. Find all the points where this graph has a horizontal tangent line. Anytime you see the word horizontal tangent line, what you have to do is set the derivative equals 0. Does this equation look familiar to you? X squared plus 3x minus 1. It doesn't look familiar? Look at your notebook. Did you work with this example today? See? How could you forget that? We just did one example. X squared plus 3x minus 1. So we already know if our f of x is x squared plus 3x minus 1, from your second example, what's the derivative of this function? Using the definition, what did you find? 2x plus 3. We found it, right? 2x plus 3? Yeah. See here? The derivative of this function is 2x plus 3. So if the original function is x squared plus 3x minus 1, using the definition you already found, its derivative is 2x plus 3. And what does horizontal tangent line means? What do you have to do? What do you have to do? Set your derivative equals 0. Horizontal tangent line means derivative is 0. Always. Horizontal tangent line is happen when your derivative is 0. When the slope of the line is 0. What type of line has slope 0? A horizontal line. So horizontal tangent line means you slope 0. What is slope? The derivative. So set the derivative equals 0 and solve for x. What's the x here when you solve for x? Minus 3 minus 3. So 2x equals negative 3 divided by 2 divided by 2. So x is 3/2. They're asking for find the point. Point. Oh man, I hate point. Huh?
Oh, I got 2x.
Using the definition of the derivative. This equation is the same equation we had here. When you use the definition of the derivative, all of this tells us once you plug in the limit, you have 2x plus 3, that's the derivative of your function. And derivative of the function is the slope of the curve or slope of the tangent line. So we are using the same derivative here. Horizontal line means it's a line that has a slope 0. So derivative is a slope, that means it has to be 0 for the horizontal tangent line. When the slope is 0, means derivative is the 0, which x value you get? It's negative 3/2. But they're not looking for x, they're looking for points. every point has two things, x and y, right? So if you know your x, how are you going to find the y? Plug this into the original function to get the y. Negative 3/2 square plus 3 times 3/2 minus 1. Find the point where the graph has a horizontal tangent line. Okay. So it's 9/4 plus 9/2 minus 1. Do you have a page? No. Oh, let me do it. Let me get a page. So x is negative 3/2, y is 9/4 plus 9/2 minus 1. In order to combine them, what do we need? Same denominator. So what is our same denominator? 4. So what do you need the 2 multiplied by? 2. So you multiply numerator and denominator by 2. And how about the 1? Below 1, 4. So you multiply top also by 4. So we have 9 plus 18 minus 4, which is 23. 23/4. So the point they are looking for is negative 3/2 and 23/4. So this graph, I don't know the shape, but this is what is happening. Here, this is -1, and this point is negative 3/2. No. The other way around. Here. So this point here is this one. Negative. It doesn't make sense. What did I do wrong? It looks like I did something wrong. Oh, it's negative. So I missed my negative. That's why it doesn't make sense. Wow. Man. So 18 is -9 minus 4 is -13. Now it makes sense. So this is the point. We have a horizontal tangent line. And see, you have a minimum there. -3/2, -13/4. So why do we care? Well, let's say you have a graph you don't know of. We don't know the shape. But you want to know where this graph has a minimum or maximum. So what you have to do, find the derivative of your function, set the derivative equals to 0, solve for x, and you have an idea where this function has a maximum or minimum. You may not know which one you have, max or min, but you have at least some idea where you have something, maximum or minimum. Next, we have a few fun examples. We have a curve, and they are saying at x equals 0 and at x equals 4, the tangent line is horizontal. X equals 0 is here. Where? Here. X equals 0, here we have horizontal tangent line. And x equals 4, we have horizontal tangent line. So this graph has two horizontal tangent lines at which x values is the derivative is negative. Means they give you the x values. You have to figure out at which point your derivative is negative. So question number 1, what is derivative? Derivative tells us what? Slope. So it says derivative is negative. It means what is negative? Slope is negative. So what type of line has a negative slope? Increasing, decreasing, horizontal, vertical. Which type of line has a negative slope? Decreasing. So the hint here, f of x, derivative of x is negative, means decreasing line. So the first one is 0. At 0, do you have a decreasing line? So this is not the right choice. At 1, this is 1, we have a point 1. If you draw a line here, is this a decreasing line? At 3, this is the 3. If you draw a line, this is the line you have to draw. Is this a decreasing line? 4. Is this a decreasing line at 4? Then the next one, 5. This is your 5, so you have a line here, you have a point here. So if you draw a line, is this a decreasing line? Yes. So answer is 5, because it has a decreasing line, decreasing tangent line. So that's all you have to do. Figure out where, if you draw a line, the line is increasing. Why you care? Because it says, so line is not increasing, line is decreasing, because you're looking for a negative slope. Who is lost? Anyone? Come on, guys, ask me something. How else I know whether to move on or to stop? Tell me your feedback. Give me your feedback. Tell me your thoughts, your ideas. What do you think? Did you understand or didn't understand?
I said 5.
So we go back to the question. It says where the derivative is negative. So derivative means what? Slope. Derivative is the slope of a line. Slope of the specific line, tangent line. Slope of the tangent line. Okay. Now, what type of line has a negative slope? Negative slope. Which type of line has negative slope? Decreasing. So the 5 points they mentioned, if you draw a horizontal line, I drew the horizontal line at every point. At 0, at 1, at 3, at 4, and at 5. Which of these lines is a decreasing line? So this is at 0, this is at 1, this is at 3, at 5. So that's what the answer is 5. Because they're saying where the derivative is negative. Means where do you see a decreasing line? Then we have where the curve, where in the curve you can have a tangent line and where you cannot have a tangent line. In other words, where can you have a slope and where you cannot have a slope? We can have a slope anywhere in the line as long as it doesn't have any problem. If you have a smooth curve, anywhere you can have the tangent line. Anywhere you can have the slope. You can have the slope at here, or there, or there, or here, or here. Anywhere if you want to find the slope, you can find the slope, as long as it doesn't have a problem. So where it has a problem and what type of problem I'm talking about? A curve is not differentiable or doesn't have the derivative or doesn't have the slope if it has following problems. Problem one is a sharp corner. For example, something like this. If you have a sharp corner, you cannot have the derivative here. So sharp corner doesn't have the derivative. Or if you have a hole, let's say you're going somewhere and then suddenly you have a hole in your graph. This hole cannot have a derivative. Or breaks. Let's say you're going something here and then suddenly you jump. When you jump, you have a break. In the break, it cannot have a derivative. And also there is one more, I forgot to put it here. And at vertical asymptote. Vertical asymptote. What is vertical asymptote? It means something like this. While your graph breaks into pieces. So sharp corner, hole, breaks, or jump. This is a jump, and this is a break. At 4 places, you cannot have a derivative. This is called vertical asymptote while your graph breaks into pieces. This is a jump. While you have a jump, there is some y value missing. It cannot have the well, it cannot have a derivative at hole and at a sharp corner. 4 places doesn't have 4 places don't have any derivative or they don't have any slope. Now, based on that, can you figure out where this graph? Sketch the graph and then find why it's non-differentiable, means why it cannot have the derivative. Where this graph cannot have a derivative. Let me take the attendance and you try figuring it out. What happened to or if this is harder, then let's do something fun. Try this. Where the derivative doesn't exist for the left and for the right. Today is what, 9/21. Dominica, Salahuddin. Salahuddin, our exam is day after tomorrow. Exam is day after tomorrow. Exam is day after tomorrow. See, I knew you didn't know that. I knew that. I sent an email and we talked about it in our last week last class. Day after tomorrow. We went over the review sheet before. And the videos are on YouTube. Arsla, nope. Maxine, Zoe, Jolene here, Prince, Hayden here, Ellen here, Asin here, Skyly, I saw you, right? Yeah. Alice here, Jasmina, Alexandra, Jennifer, Jessie, Johnny here, Afiz, Tarin here, Pedro here, Erika here, Jawad here, Ruby here, Sayom here, Dimitri here, Amir here, Siki here, and William here. Oh, only 2 absent, Afiz and Arslan. Okay. The left or the right? Oh, I know, I'm going to extend that because my MATLAB has, is it still having the issue?
Yeah.
Yeah. So I cannot even extend anything now. I cannot even get to my MATLAB. But don't worry about the homework. I'm going to extend them. Sure, no problem. As long as you do them, they're very important. 10% of your grade. Without them, there is no way you can get A or A minus in this class. Trust me. And after your second exam, I'm going to show you a calculator. You'll be surprised to see. It doesn't matter if you get 100% in the exam. If you don't do your MyMathLab, it's going down. From 100%, if you subtract 10%, what do you get? Journey, help me with this one, the right page. It says where, for which x values, the derivative doesn't exist. Doesn't the derivative exist here? Does it exist here? Does it exist here? Then why are you saying negative infinity to here? I'm talking about the right page. Right. At which x values the derivative doesn't exist. Yes. So we start from here. Do you have any problem anywhere from here to here? No. No. Then where is our first problem? At which x value? X equals 1. What's the problem at x equals 1? Sharp corner. So our first problem starts here. X equals 1. It has a sharp corner. So x equals 1, there is no derivative. And then we move on. And then what happens here? It's a hole. So what's the x value? 3. Here we have a second problem. It's a hole. So x equals 3. Then from here we're going on until we reach here. What's from here? It's a jump. It's not a hole actually. It's a jump. So this part has a problem. It's a jump. What's the x value here? 5. So from here, you suddenly jump and then you go. Do you have any problem anywhere here? The end has a derivative. Derivative doesn't exist 4 places. Sharp corner, hole, jump, and then you have vertical asymptote. This one doesn't have any vertical asymptote. So at these places, there is no derivative. One last question. The left page. It says, is it piecewise function? Yeah, last question. It's a piecewise function. When x is smaller than x, we have a parabola. So here you have a parabola. And then when after x equals 0, we have a line y equals -2. So this is y equals -2. When you combine the 2 pieces, we get a complete graph. It goes here and then there. So it goes here forever, and then it turns here. This graph, is there any place where the graph doesn't have a derivative? Do you see any place with any problem that doesn't have a derivative? We don't see any problem. This entire part has a derivative because continuous. This entire part has a derivative because continuous. And here, these two lines, they're connected with a smooth shape. So it doesn't have any problem. So it says where the graph is non-differentiable, the answer is nowhere. Nowhere. It means the derivative is exists everywhere. Compared to that, one last question. This one. It says the first graph is 4x before 1. So if this is 1, before 1, it's 4x. I mean, how do you graph 4x? Increasing, right? 4x is in, it goes to 0. So this is 4x. Before 1, you have 4x, and after 1, you have a 4 graph. So y equals 4 and y equals 4x. Now we know from here to here, there is no problem. It's continuous. From here to here, there is no problem because it's continuous. The two pieces, they don't have any problem. But how about the intersection? It's a sharp corner. So this intersection has a problem. So it's not differentiable at x equals to 1. Not differentiable. So this one is not differentiable because of the sharp corner, but the other one is differentiable because this is not sharp corner. It's a smooth corner. Okay. With this, we are done at 2.1. When we come back, we are going to do 2.2, 3, and other stuff. Not yet. So start smart, guys.
Like one, the homework is due today. Is that
No.
okay? Okay,
I have to change it.
okay. And then you said I'm gonna do 1.6, 7, and 8 today.
If it's available.
I'll check.
Okay.
Let's talk about that. The hole couldn't have. Doesn't matter what color the hole is.
Color. The color doesn't matter. The thing. Oh yeah. Hole. This is not a hole. This is a complete circle. This is a hole. This is a hole. Okay. Now the difference between these two holes is that this is actually a jump. Because from here, you have to jump to go to the other part. But this is a hole because you're walking, you suddenly hole, you fall down and you come back.
When you're sketching it, how do you differentiate if it's a sharp corner or a hole?
X square is it's a parabola, right? So it's a smooth turn. When you draw your parabola, so it says, let me erase all of this. It says before 0, you have a parabola. Parabola, so it goes like, it goes like this. Because smooth, right? And then y equals -2 is a straight line. So you go a straight line here. So the curve, the parabola and the line, where they connect, how did they connect? With this smooth connections or with a rough, straight, sharpie connection? Okay. How do you see it? It's a parabola, and then the line is going on.
Yeah.
It's a smooth compared to this one. It says you have a straight line. You're going straight, and then suddenly you're going on a horizontal line.
Oh.
So straight line, straight increasing, and a horizontal line. How do they connect here? The intersection. You have a corner. So this one has a corner, but this one doesn't have a corner. It's smooth.
Okay. That makes a lot of sense. Thank you. Have a good day.
You too.
Professor, I have a question. Like, I didn't understand this one that you did at all. What's in the best way?
Okay, so what we did was to find the derivative. To find the derivative, this is the beginning, so you have to use the definition. So to memorize the definition. The definition says limit h goes to 0 of this difference quotient. Now we talked about difference quotient before. So if we have this function, how do you find the difference quotient? You substitute x with x plus h, expand, and then you subtract the original function. So this is your x plus h whole thing. And when you subtract the original function, all of these, they will change their signs.
Okay.
So the difference quotient minus your original function with changing sign. Here I actually did two steps
After
in
you
one step.
explained it, right?
So this should be actually the correct way, not correct, more formal way is this. F of x plus h minus f of x means we have x squared plus 2xh plus h squared plus 3x plus 3h minus 1, and you're subtracting your f of x, which is the original function, which is x squared plus 3x minus 1. But when you subtract, what happens to the sign? It changed. So instead of writing this line, when I was lazy, so writing this line, I just changed everything. And then, so original f of x plus h minus original function f of x squared cancel out, 3x cancel out, 1 cancel out. You're left with xh, 2xh, h squared, and 3h. And definition has e with h in the denominator. So this is divided by h. Again, I got lazy. So this one,
It's like the first one you did, but it's like little more steps.
because the first one had only x squared. This one has x squared plus 3x minus 1,
Yeah.
3 times. So one word. So once you cancel out everything, you have 2xh plus h squared plus 3h divided by h. And then we have to cancel the h's. So what I did, I just split it up. You can split them, or you can take out h is a common factor. It's up to you. But I found splitting is easier because you can see h divided by h.
But cancel.
So you see all of them. You're left with 2x from here because h cancel out. And this cancel out here and here. When you cancel these two, you're left with h, and this h cancel out. So once you have no more denominator, this time you can substitute your a to 0 because this is what limit makes. At the end, see when your a is 0, what happens to the function? So you have 2x plus 3. This is the derivative.
Also, you remove the h completely.
You get 0. It is 0. So 2x plus 0 plus 3, 0 plus 3 is 3. So 2x plus 3 is the derivative. So
And
definition.
then you just plug in.
Now it says this is the derivative at any x. But you're not looking for any x, you're looking for exactly x equals 2. So what is the derivative when x is 2? Means what is the slope when x is 2? So slope when x is 2 is 7 because when you substitute 2 here, you get 7. So this is the slope at 2. This is the x value at 2 and y value at 2 we found 9. So when x is 2, y is 9, and our slope is 7. You substitute all of them into your equation y minus y1. Good news, in the exam, I'm going to ask you for the definition.
Will it be on final?
Not the definition.
Not the definition.
So after the exam, we are going to do the same thing
But
without
easier?
definition. Much easier.
Okay.
We're just going
This
to,
one is.
I know. For the beginning, we have to know the definition.
Yeah.
But eventually you learn the rules. If you know the rules, there is no more definition needed.
Thank you so much.
You too.